In this video, we're going to take another CODAP example document here and illustrate how you can develop a CER activity, a claims evidence reasoning, focused around a specific question or phenomenon. So in this case right here, I'm going to look at the periodic table. Okay, so the periodic table is illustrated right here, and there's a guide here should you choose to use this or any of the other activities. You generally provide a guide which will help you kind of with your analysis. So what we have here is just some plots. We can see here that this is a graph where we're just plotting on this axis here the natural states. In other words, what is a natural state? So this is a graph of the periodic table. We'll move that off. And then these represent the elements in the periodic table from atomic number, name, and so forth. So what we did here is we simply took here the database and we said, okay, I'd like to plot the natural state. And so we took a document here and we just said, okay, let's just go ahead and put that over. Now, if I drag something else over instead, like the crystal structure, we can see that most crystals, most of these elements are hexagonal. Some are cube face centered and so forth. So it gives us some way of just showing the distribution. If I look at the discoverer, we can see, wow, okay, that a few people like Glenn T. Seaborg of the University of California basically discovered many elements. These are all unstable transuranium elements and so forth right here. But we can see other individuals who discovered those. So if I want to look at any other variable here, I can just simply put it on that chart. So let's say I'm looking at, again, I'll just delete that and show you where I got that. I got that from a graph. And I was just plotting one feature. But let's say I wanted to look at something else. Like let's say I wanted to look at the electron affinity, all right, versus some other attribute, okay? Now, again, you don't need to understand the chemistry to see what I'm doing here. I'm just plotting two things versus each other. And so what I'm looking at is I'm looking for the electron affinity as a function of atomic number. All right, so when I look at this, it may just look like a scatter to you. But as you start to look at more detail, you're going to probably start to see some repeating patterns. It looks like every so often there's something up here with a very high electron affinity. And then every so often there's something with a very low electron affinity. So if I can go over and look at the various different variables, I might like to put onto this maybe like a table column. So I'm going to drag onto this, the column where it appears in the periodic table. And now we can see that the darkness here represents the higher the number. So we can see that if it goes to number 17, in other words, if it happens to be over here on the right side, that we're seeing that those tend to be those higher values overall there. So we're starting to see some kind of relationship between these things. Now, let's say I look at atomic number and I want to look at atomic weight. So I'm going to compare atomic weight. I put atomic weight versus atomic number. And there we see a very clear trend, okay? But superimposed on it is the table column number. And so we can see that it looks like there's a repeating column number, and that makes sense. You're going from, as you go from 1 to 17, 1 to 17, and so forth like that. We're seeing that pattern repeat itself there. Let's put melting point on here. And now we're looking at melting point. And again, we see these bands where there's very high melting points, low melting points, high melting points, low melting points, and so forth. So it gives us an opportunity to look at data in a different way, to start asking some questions. Now, again, it obviously is easier if the students have some kind of a knowledge about what they're, the features they're talking about. I'm going to look at year discovered versus atomic number now. So let's say I'm a historian and I kind of go, wow, okay, it looks like at least these very high numbers were discovered very recently. So we can see that all of these ones from element number like 90 or so on were not discovered until the late 40s and to present day and so forth. So these elements right here are perhaps there's something about being a very heavy element that made it difficult to discover. And again, these are very rare, naturally occurring ones, and these are all ones that are made in nuclear reactors. And so, again, the idea is whatever data set you look at, is you want to start asking a question like, why do we see these patterns? Now, this would allow me to make a claim about the kind of the atomic structure, and this is actually what chemists have used for a long time to develop the model we have of the atom. And the key thing we're looking here is that we develop what's called the periodic table. And the periodic table is periodic, means that there is some kind of period, some kind of repeating pattern. And again, the repeating patterns may not be that evident until we start to look in a little bit more detail. Let me just put down the ionization energy. And I'm going to click ionization energy as a function of time here. So now I'm seeing ionization energy. And now we start to see a very clear pattern. We say, wow, look at this. It goes up and then down, and 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 up and down. So we see a periodicity to it. Well, that periodicity is reflected in the periodic table here. These elements with very high numbers, so if I click on something here, it shows me where that is. It happens to be in family 18. All right, click here. Oh, that's also in family 18. That's in family 18. That's in family 18. And so you can see here that these high numbers represent elements in the periodic table that are in the last column. And you might say at the period of a sentence. And this periodicity is the idea is that there's not randomness, but there's actually order and organization in the elements. And now we can actually springboard into chemistry, realizing it's not something you need to memorize so much as something you need to figure out, take some basic principles and apply it. And that's the beauty of developing strong data analysis skills, is being able to look at patterns. Then you can start to make some inferences. And again, for this particular exercise, you want to ask a question, make a claim, present the evidence, and then show your reasoning, whether it's scientific principles or the principles relevant to your discipline.